Hello everybody and welcome back to Environmental Science 101. For the final video in this unit, we'll talk about air pollution. I chose this photo because it was among the first thing that came to mind for me, and it's also not that long ago. There were wildfires up in Canada. This would have been mid-summer 2023, and as a result of complicated changes in circulation, pollution from that wildfire smoke ends up traveling all the way to New York City, giving it, I believe, the worst day of air pollution on record, although it did not last for terribly long. And I just pulled this out as an example. Folks living their lives in the city, regardless. Truth be told, I would probably have to recommend these people to not do yoga outdoors on this day, but it's their life. We'll just give them information. Okay. So, before we talk about air pollution and all this other stuff, I'm going to take just a moment to be optimistic and give us some context, right? So I will get out of the way here. There we go. So life expectancy, right? One of the foremost indicators of how healthy a population of people is, right? It's gone up over time for all of our different continents. We can see labeled in our different colors since, well, we can start with, right, the beginning of industry. We can actually notice how terribly low some of these life expectancies were, right? And how drastically they've improved all the way up to the present day. And as a fun fact, a very significant portion of the improvement since about maybe here in the 1950 to 1980 area, especially in the developed world, comes from a single factor, and that is the fact that people smoke less. So stop doing that. Anyway, optimistic. Life expectancy going way up around the world. We can see it's not equalized between our different regions, and this corresponds heavily to levels of development and GDP as well, but overall getting much better. Child mortality rate is doing the opposite, which is also good, right? So we start at 1800. We have industrialization, right? Child mortality rates, again, as high as 30 or 40%. Varies heavily depending on where we are, depending on status, depending on the events of the time, right? But not so great, right? In other words, if a person had 5 kids, then they could rightfully expect only 3 of them to survive into adulthood, or in this case, right, past the age of 5, even worse than it appears. We can notice that this has fallen dramatically over time, right? And I wanted to include this just to put some of our discussion of pollution and air pollution into context, right? That over the big, long arc of everything that has happened since this year 1800, there's a lot of indicators that things are doing much better for many people, despite all of these problems. And I just feel this is helpful to keep in mind, because if we think that things are only getting worse no matter what, then it also makes us feel helpless. We forget that we can play a role in them. Awesome. So, yes, less of an optimistic idea and more just the state of the world. Going to keep me up here, urbanization, right? Among all the different trends that affect human beings and how they live and work and use resources and pollute is probably factor number 1, right? As far as what is going to change over time here. Going back even to 1960, right? So we have our urban population in red, rural in blue. And this is for the entire world. We notice that the urban population going way up and the rural population evening off. There is every reason to believe that this will continue. I'm not a huge fan of projections or predictions in general, but we should expect this rural population actually fall off a little bit and the urban population to go up. And in many cases, people are moving to the city to get better jobs than their lives were before as agricultural workers. There's cities, we have social mobility, we have opportunities to earn a lot of times like 10 times as much as people could earn by farming. So this can be difficult, right? Somebody goes from their rural farming village all the way to the city, could be hundreds of miles away in a place where that's an even bigger barrier than it is for those of us here in the States. And they send money back, and since they're making so much more than they could by just growing crops, they can finally afford things like shoes, watches, send the kids to school, maybe have a wedding. This is good, right? This is something that they want. This is, broadly speaking, a good thing, even though it comes with many side effects. And not to jump ahead too much, but when we talk about sustainability, we will talk about the problems, right, with urbanization. Broadly speaking, just to cut to the chase on that one, cities can be a lot more efficient and a lot more ecologically friendly and sustainable than rural living. They can be that, but this thing happens socially and culturally, where people who move to the city demand more and consume more and compete in these social hierarchies that are mainly defined by consumption. So even though the cities could be so much more efficient, they don't end up being that way because people who move there just start to demand more and consume more and waste more and pollute more. We will return to that later when we do sustainability. Our data here is essentially summarizing the same thing, right? So our share of urban population by continent, 1950, not going quite as far back as our previous page did, but co-equal with our graph here, all the way up to 2020, right? We can see massive changes here, particularly in Africa and Asia. We might also remember that these are places where the population is increasing the most quickly, broadly speaking. So definitely these two, right? Africa, especially sub-Saharan Africa, and then Asia, especially East and South Asia, are in a category of their own in terms of population, in terms of the way that they are developing, in terms of changes that we should and might expect. But it's across the entire globe, right? It's not limited to one region or another. We can see similar jumps, albeit smaller, right, in more developed areas. Latin America, Europe, North America. Urbanization is happening everywhere. We should only expect it to continue. We can also notice the break-even point of 2009. Awesome. Okay, with all of that context, our reasons to be optimistic, and our understanding of urbanization as this trend that is really defining environmental impacts at the scale of the modern global world, we can get into the policymaker side of it, or the we need to make hard decisions side of it, right? And our framework for how to make those decisions from the lawmaker perspective, right? We're talking about public policy, legislators, governments, laws. When I say policymaking, it's going to include the broadest sense of public policy. What should they be the most worried about, right? How do we organize all of these impossibly different, big, large trends and make sense out of it and then come to some sort of decision? So I've chosen EPI as a framework here. It is data-driven. It is organized by Yale. It is very, very well done. We will start in the middle as our way to understand this, right? So I am a lawmaker. I am some politician, policymaker of some kind, and I'm trying to figure out, this environment thing, right? What is more important? What is less important? How do I need to think about it? How do I focus? We divide it into 3 areas right away. So we've got ecosystem vitality, right? Which is going to be 40% of it. It's our biggest share. However, not too different from the others. These are almost equal into thirds. And this is going to include biodiversity and habitat, which coincidentally we have talked about so far. Okay. Ecosystem services in particular, which we have also talked about, knocking out the 2 biggest chunks here. Ecosystem vitality, right, is going to focus on the natural world, right? Biota. Environmental health is going to focus on the impacts of especially pollution on human beings, going to make up about 20% of the entire thing. And what is going to be the biggest aspect of environmental health for us to focus on, making up a full half of it? It's going to be air quality, right? The rest of this is focused on the way that environmental factors and especially pollutants impact human beings, which is how it is distinct from this domain of ecosystem vitality. We also have climate change as its own huge bucket here, making up 40% of the weight of what we should be worried about. I am going to leave climate change aside for now. We are going to get to it later. We're going to focus on these 2 areas, right? So we have covered biodiversity, ecosystem, services. We have sort of touched on these. We're going to move to air quality on the environmental health side of it. Awesome. Just for reference, to put this into context of the entire world, and it really drives things, right? We've got GDP per capita here in US dollars, thousands, right? And it's a log scale. In other words, it's an exponential scale. So we've got poor countries, countries with fewer resources who produce less. Then we've got wealthier countries on the other end. And what do we notice is as the level of wealth goes up, right, our EPI score goes up. This is not the strongest statistical relationship, right? But we can see an extremely strong and clear relationship between this. And if anybody's curious, here is the US, and here are some of the countries who are doing the best in terms of their environmental performance. Awesome. Okay, so air quality. We are going to break it into these different areas. Now, we could discuss some of these others, the VOCs, volatile organic compounds, and carbon monoxide. We're going to focus on these four for now that are going to be the most important for us. And we can notice the breakdown in terms of weight here. So, particulate matter, aka PM, is where we are going to start, typically subdivided into these two groups, 2.5 or 10. That is the number of microns or micrometers. Micrometers is a millionth of a meter that the particles take up. The smaller the particle, generally speaking, the worse it is going to be to breathe it in, right? And the harder it is going to be for your body to deal with it. So this is our human hair, just for reference, 50 to 70 microns. Here is our grain of sand, especially fine sand, and our particulate matter particles, right? The big ones are going to be here, so dwarfed by the size of a strand of hair. And the PM 2.5, really, really small particles, especially from combustion products, are going to be so small that you would have to zoom in, even if you were already zoomed into the scale of a human hair. This is bad. This stuff gets into the lungs, it blocks the gas exchange process, damages cells. What is the source of this particulate matter that is all in the air? Broadly speaking, we're going to talk about wildfire, power plants, and vehicle exhaust as being our sources for this. What are the effects that it has on human beings? Not good for the heart and lungs, right? Can damage lung function, especially in children, unfortunately. Can contribute to heart disease. I don't know if we could say that it causes it, but it is a risk factor. And the development of asthma, again, particularly in kids. Not good. Household solid fuels. Now, this is not something that is measured in the air per se. It's a little bit different from particulate matter and some of the gases we'll talk about next. But if we go back to our environmental performance index, right, is a huge proportion of air quality, right? So we're talking about folks burning stuff inside their homes, right? Fire, coal, charcoal, that is going to produce a lot of smoke and generally not be good. We talked about house coal in England, its roots in 14th century, and about how it was banned nowadays. And now we can see that come back around, right? Sources tend to be domestic, cooking, heating, fire. Effects are going to be pretty much the same as the effects of particulate matter, right? It's going to produce a lot of that. Not good. Next is ozone. Yes, this thing. So ozone is made of oxygen, 3 of them put together. We don't really need to worry about that, except to understand that ozone can be created within our atmosphere, which, as we recall, is 20% oxygen. Ozone. It's not good. It's poisonous, so stop breathing it in, please. Okay. Vehicles, industry, and energy, which you notice are extremely similar to our other sources. If you go back, wildfire, power plants, and vehicle exhaust, we'll notice that energy creation and vehicles are going to be a common theme here. Effects of this one. Damage the airways. It's not good for lots of reasons. This one tends to form more when you have really high temperatures on the ground due to reactions with oxygen in the air. And this also commonly comes up because students have heard of the ozone hole. Now, we will do so much more on this when we talk about environmental science and law. This is one of those cases where the environmental science side won and did really good. It's a success story, but we'll talk about it later. Nitrogen dioxide. Sources, nothing new. Vehicles, manufacturing, effects, it hurts your lungs. This one we don't need to be focused on too much. Particulate matter and ozone are going to be the most important. Now, in the US, what has been done, right? I will move myself back down here. We might see our air quality index or be familiar with it as a measure. This is generally going to be an aggregate of particulate matter, ozone, and some of the others. I just included this as a sample. It's pretty good when I took it. This is passed in 1963. It has been amended many times. It is at this point administered by the EPA, though we'll remember the EPA wasn't around until 1970. It is going to regulate 5 pollutants, some of which should be familiar to us. So the particulate matter, ozone, carbon monoxide, sulfur dioxide, nitrogen dioxide. It also regulated lead. Lead is in its own category. This has also been a big success in terms of making policy that is informed by environmental science that has a huge benefit to human health. Okay, we skipped some slides. I will have to put those into notes. What are our big questions? So the change in biodiversity over Earth's history, the big timeline, its trend overall, the mass extinction events and the connection between those and climate, the way that global circulation patterns control climate, especially precipitation, and then by extension, ecology, the relative importance of biodiversity, ecosystem services, and pollution, especially those domains and their different weights, and then finally, the impacts of air pollution on human health. Thanks.